So now that we've looked at tangents in a bit of detail, and we understand that the gradient of a curve is essentially where the tangent, the gradient of the tangent that touches the curve at a particular point. So now that we've sort of grasped that concept, I'm going to take it a step further. We want to look at something called a normal, right? And normals to a curve are essentially where the tangent is perpendicular. No, what line is perpendicular to the tangent? That's a normal. So similar to how in linear equations you have, your parallel and perpendicular lines, and say if your m1 was equal to 3, then to find the gradient of the perpendicular line, you would say, m2 is equal to -1 over m1, which would be equal to -1 over 3. So we're going to use a similar concept to find the perpendicular line to the tangent. In yeah, in a scenario where we have curves or quadratic expressions or cubic expressions, right? And again, we'll realize the application of that later on when we start doing graphing and optimization problems and application problems like that. But to start us off, I'll give you a simple example as to what it means and how we can calculate that, right? So first thing we're going to do is question 1a, and we're just going to look at a normal tangent, right? A normal tangent, finding the equation of a tangent question, something that we've already done. So we've got a simple equation as well. So we've got y is equal to x to the power of 3, and we've got the point a is 1 and 1. So we're just going to differentiate this first. So we're going to differentiate with y with respect to x, which is equal to 3x squared, and then want to find the gradient at point 1, 1. So when x is equal to 1, our dy over dx is equal to 3 times 1 squared, right, which is equal to 30. Okay, so that's basically our gradient is equal to 3, and we've got our 2 points. So now again, using the width gradient formula, we can find our equation of the tangent, right? So y minus, our y coordinate is 1, our gradient is 3, and our x coordinate is also 1. So y minus 1 is equal to 3x times 3, which means that y is equal to 3x minus 2. Okay, so that's the equation of our tangent. Now for the normal, as we said, the normal is the line that is perpendicular to the tangent, right? So if the gradient of our tangent is 3, so I'll just write this as m1, then the gradient of our normal is going to be -1 over 3, right? Similar to how we similar to what we said over here, right? It's just m2 is equal to -1 over m1. Okay, now it's going to be the same points as you can see here. It's asking us for the same points at a is equal to -1. So again, we're going to use a point gradient formula. So I'll write it down again. Y minus y1 is equal to m x minus x1. So again, our y coordinate is 1. The start gradient now is -1 over 3. And our x coordinate is still 1 as well. So y minus 1 is equal to -1 over 3 x plus 1 over 3. Then if you bring the 1 to the other side, that becomes y is equal to -1 over 3x plus 4 over 3. And that's the equation of the norm. Okay, so again, I will put this in decimals and see what that means. You'll see what these lines mean. You'll see, if you've got you draw a graph here quickly. Not a graph like that. We don't need that line there. So a graph like this, where if you've got a graph like that, and then let's say we have, our, let's say we have our curve, which is something like that. So we're looking at the point, x is 1 and 1. So let's say this point over here is 1 and 1. Okay, so in another color, I'll say that the equation of the tangent, let's do this properly, so let's draw a line. So the equation of the tangent is going to be here. So, right, that's the tangent at the point 1 and 1. Okay, and the equation of this tangent was what we calculated. the equation of this tangent is this equation here. Okay, so if you write that equation down, y is equal to 3x minus 2. So now the equation of the normal is where this tangent is perpendicular. So again, if I use a different color again, let's use green. And if you draw another line, the equation of the tangent is going to be where it is perpendicular. So it's going to be at this point again, 1, 1, because we're crossing that same point. Okay, and we're just imagining that this is perpendicular, right? So imagining that this point is perpendicular. So this is the equation of the normal, okay, which is what we've set as y is equal to -1 over 3x plus 4 over 3, right? So this is, I'll just label these. So this is the normal, and in red, this is the tangent. Right, so I hope that clears things up, and I hope that starts to make sense about what we're referring to when we're saying tangent normal, what we're saying, what these equations actually mean, so that the -1 over 3, we can see that this tangent has a negative gradient here. This +3, we can see that this gradient is positive here. So we can see that not how it just follows us basic linear equation rules, but we're just applying that to our calculus now here. Okay, so now using all this knowledge, we can do the second question as well. So second question, we have to differentiate. Let's zoom out a bit here. Second question here is to differentiate y is equal to x squared minus 8x to the power 4 plus 19. And we have to find the equation of the tangent and the normal at point 3 and -1. Okay? So let's differentiate this first. We've got dy over dx is equal to 2x minus, bring the 4 down, so 8 times 4 becomes 32, and the power goes down by 1. And then the 19, that's the sequence, so we can get rid of that. Okay, so this is our derivative. Now we want to find the equation of the tangent at the point 3 and -1, right? So let's sub in this x value to figure out what our gradient is going to be at x is equal to 3. So x is equal to 3, our dy over dx is going to equal to 2 times 3 minus 32 times 3 squared. Okay, got to need a calculator for this one. So 2 times 3 is 6 minus 32 times 3 squared. And that is -282. Okay. So this is our gradient, basically. Our gradient is -282. Big number, right? But anyway, that's for our, so I'll label that as M1 as well. So we know that this is the equation of the normal, of the tangent, and we can find the equation of the normal label. Therefore, the tangent, so again, using a point gradient formula, y minus y1 is equal to mx minus x1. And then we can use our point. So our y coordinate is -1, so negative becomes +1 is equal to -282. It's a big gradient. X minus 3. Hey, so y plus 1 is equal to -282x, and then 282 times 3 becomes 846. And it's positive because we're multiplying the negative with a negative. And if we just bring the 1 to the other side, we get y is equal to -282x plus 845. Okay? And that's the equation of the tangent, right? So let's just put that as tangent. Okay? And then now to find the equation of the normal, we're going to do the same thing. This m2 is now going to be very small. It's going to be -1 over -282. Right. So which is just equal to 1 over 282. Okay. So now again, using our point gradient formula, y minus y1 is equal to mx minus x1. And that means that y, again, it's going to be the same coordinates that we're using. It's the same point. Because they haven't, yeah, we're finding the same point for both the tangent and the normal. It's using the same point, y minus 1 again, which becomes y plus 1 is equal to 1 over 282 min x minus 3. That becomes y plus 1 is equal to x over, okay, I won't write it like that, I'll put it separately. So y plus 1 is equal to 1 over 282x minus 3 over 282. And then the y is equal to 1 over 282x. And then we've got minus 3 over 282 minus 1, which becomes simplified minus 95 over 94. Okay, and that's the equation of our normal. So I'm not going to graph this one because the numbers are a bit too messed up for this one. But again, if you want, you can go into Desmos and see what it means, and you're going to get a similar result to this. So we've got the tangent here, and that's the equation of the normal. So again, just to highlight it, that's our tangent. Okay, and this is our normal. Okay, so then normal is the one that is perpendicular to the tangent. Okay, similarly here, this is our tangent, and this is our normal. Okay.